Hello everyone, welcome to SuMON student presentation. Today we have Gahan Mukherjee of level 4. He's an avid learner of advanced mathematics. So he is going to explain to us a problem from last digit of a number which is raised to itself. So it is going to be interesting and it uses congruences that is a part of Olympiad mathematics. So let's get started.
Today I'll be presenting problem 6 from fortnight 10. So problem 6 basically says that let mn be two natural numbers such that m is congruent to n mod 20. Then we have to prove that the last digit of the numbers m to the power m and n to the power n are the same. So in order to solve this question, we have to divide it into 4 cases. So in case 1, we have GCD of m and 10 as 1. In case 2, the greatest common divisor of m and 10 equals 2. And in case 3, the greatest common divisor of m and 10 equals 5. And finally, in case 4, the greatest common divisor of m and 10 equals 10. Now we will do case-wise analysis and exhaust all cases to prove the given statement. So in case 1, we have that GCD of m and 10 equals 1. Therefore, we can easily apply Euler's theorem. So first we observe that phi of 10 equals 4. Also, since m is congruent to n mod 20, we can say that m minus n is divisible by 4 or phi of 10. So we can say that m to the power m minus n is congruent to m to the power phi of 10, which is congruent to 1 mod 10. Therefore, m to the power m minus n minus 1 is divisible by 10. For m to the power n times m to the power m minus n minus 1 is divisible by 10. So we can say that m to the power m is congruent to m to the power n. Now m to the power n is also congruent to n to the power n mod 10. So m to the power m is congruent to n to the power n mod 10. And we are done. So we've proved the statement for case 1. Now in case 2, we have the GCD of m and 10 equal to 2. So we can easily write m as some 2r for some r belonging to a set of natural numbers. And also the GCD of r and 5 equals 1. Now since m is congruent to n mod 20, we can write n as some 2s. It suffices to show that m to the power n times m to the power m minus n minus 1 is divisible by 10, which immediately proves the result. So m to the power n times m to the power m minus 1 in this case is 2r to the power 2s into 2r whole to the power of 2r minus s minus 1, which is clearly even. So we just need to prove that 2r whole to the power 2r minus s minus 1 is divisible by 5. Now we notice that m is congruent to n mod 20. Also, 2r is congruent to 2s mod phi of 5, which is 4. And also, GCD of 2r and 5 equals 1. So therefore, by Euler's theorem, we can easily say that 2r whole to the power of 2r minus s is congruent to 1 mod 5. Or we can say that m to the power n times m to the power m minus n minus 1 is divisible by 10. And we are again done. So now we proceed to case 3. Now in case 3, we have the GCD of m and 10 equal to 5. So m equals 5r for some r belonging to a set of natural numbers, and r is also odd. Now since m equals 5r is congruent to n mod 20, you can easily say that n equals some 5s for some natural s. So we have to show that again m to the power n into m to the power m minus n minus 1 is divisible by 10. Now, in this case, this expression is basically 5r whole to the power of 5s into 5r to the power 5r minus s minus 1. Now, clearly, this is divisible by 5 and also 2 because the first term, 5r to the power 5s, is divisible by 5 and the other term is divisible by 2. So, therefore, m to the power n into m to the power m minus n minus 1 is also divisible by 10. Now, case 4 is rather evident because we have GCD of m and 10 equals 10, or basically 10 divides m. Now, since m is congruent to n mod 20, we can say that m is congruent to 0 mod 10. Also, n is congruent to 0 mod 10. Therefore, clearly, m to the power m is congruent to n to the power n, which is congruent to 0 mod 20. And we are done again. So, initially, we divided the problem into 4 cases and proved that the last digit of both the numbers m to the power m and n to the power n are the same in each of these cases. We considered cases where the greatest common divisor of m and 10 were respectively 1, 2, 5 and 10. Since the greatest common divisor of any number and 10 belongs to the set 1, 2, 5 and 10, we can say that the 4 cases we considered were the only possible cases. Hence, we exhausted all possible cases. Therefore, we come to the conclusion that for all mn belonging to the set of natural numbers, if m is congruent to n mod 20, then m to the power m is congruent to n to the power n mod 10, or the last digit of these numbers are the same. So this is proof.
I hope you enjoyed the video. Join us to solve more intriguing problems like this. We solve non-routine problems that are not a part of JEE or NCRT or usual school syllabus. We will meet in the next SuMON student presentation. Thank you. Bye.